Yeah, good day, guys. Today we'll be converting this set of architectural layouts to structural layouts. So first of all, we start by duplicating the files so we don't mess up with the original file. So now we can start removing the text, the furnitures. These are stuff that doesn't really concern the structural engineer or whoever is doing the structural design. So I'm trying to switch it off using the layer since that's way faster. The windows, taking them off. They are not really structural members, so we don't really need them in the layout. The windows, the doors, but we need to be mindful of where they are. So especially when inserting columns. So now I'm trying to make the walls one unit because they were all broken due to the windows, the doors. So I'm trying to make the walls just one. So that's the chamfer command. So like areas where we have toilet partitions, I took them off and make them just one panel. I prefer to have my designs having less beams, more panels, more beams, more costs. And sometimes more beams requires more columns. So everything still boils down to the structural engineers' risk appetite and level of experience too. So I'm checking the distance, that's the span of each panels. So if it's above, say 5 meters, 6 meters, 7 meters, 7.5, it all depends on the structural engineer's risk appetite and level of experience, like I said before now. But I'm just checking it so that you guys can see what I'm doing. So that's a sliding door. I think it's a glass one. So we have to have a beam above the door. So basically what we're doing is converting the ground floor into our ground floor layout. So we use the walls, the partition walls the architect provided, use it as a guide to introduce our beams, meaning that our beams has to flush within the walls. Likewise, our columns, they have to hide within the walls. So the architectural walls are there to guide us. Here we have a toilet. So instead of having three panels there, I will take off the toilet, the wall, marketing, the partition, one partition in the toilet, and make the area one panel. So look at the meter, it's just around 5 meters. I think our beam should be able to take care of that panel. So there are different ways to go about this. Even if the panel is more than that, maybe let's say 6 meter by 6 meter, we can introduce what we call hidden beams. Some people call it flat beams, and increase the reinforcement spacing just to give the slab more strength. So this is not something one should be worried about. And most people get worried about when they start seeing 6 meter span, they start panicking like, oh, how is this gonna work? Mm. So I'm trying as much as possible to make sure my lines are just one, because sometimes on AutoCAD your lines might be overlapping. You'll be thinking it's just one line, but there's another line on that same line. So those are also some of the things I'm trying to take into consideration. If you notice, every beam member, I'm making sure it's just one continuous line. So as you can see, I'm joining everything to make it one line, not broken. So that's the join command, J, enter. By the way, I'm using AutoCAD 2025. So, but I'm using AutoCAD Classic interface because I started with AutoCAD 2005, 2007, I mean. So I'm so used to the classic interface. I'm not used to this new interface. So basically, my point is the way my tools and everything works might be different from yours, depending on the version of AutoCAD you are using. That's the staircase. Extending the beams. Please don't forget to like and share. That will really encourage us to do more videos like this. If you notice, I've not been uploading stuff like this for some time on my page. It's because the level of engagement hasn't been encouraging, you know. So don't forget to subscribe, like. So I just took off the toilet partition and just make that whole area one panel. That's a corridor, a small corridor, and we have to extend that beam. So meaning the beam will be showing in the corridor, but since it's not really What should I use here? I think that should fly. Yeah, that's the beam now. It's gonna show on the corridor. That's very small corridor. So I just made a mistake. I need to delete this and undo, then come back. Before that, I had to copy it. Yeah, yes. I want to keep the architectural layout the way it is. I mean, the way it was. Remember at the beginning, I had to switch off all the layouts, to do some stuff. Yeah. So I just want it to look like this exactly. So I can easily benchmark the architectural to the structural I'm working on. So that's why I have to undo and that. And yeah, I think that's a sliding glass. I don't really know what the architect did here, but I think it's a sliding glass. So I had to be sure we have a wall in that area, and to also not, and also I'm also taking the void as a cross sign in front into consideration. So this video is going to be in two parts, part one and part two, due to the length of the video. And if I see the level of engagement this video gets, I will also run this layouts, both the ground and first floor. I'll run them on Prota structure. That is, I will generate the structural. I'll run the structural analysis on the. Like I said, don't forget to like and subscribe. So what's going on here basically is the cross sign there is saying that we have a void above in the living room area. Meaning that if you're in the living room, if you look up, you see it's an open void at the top. Windows from those on the first floor, they can, if they look down, they can see the living room below. So that's what that cross sign means. It doesn't really concern the ground floor. It's just showing us there's a void above on the first floor level. So you can see me going back to the main architectural drawing and this proposed structural layout. You can see me going back and forth, just benchmarking them, looking at how the walls are going, and also giving myself an idea on how I want my beams to go. You know, we try as much as possible not to have beams running an open space. Like if you have if you're in the sitting room, it's not pleasant for you to have a beam running across in such an open area, sitting room, bedroom, So we should try as much as possible not to have beams running in such area. Even though most times people might use POP and all that to cover those beams, but we design as if they won't do that, because because most of these jobs you might not even be on site to supervise the construction, so you don't know what the client is gonna do. You know. So we have a glass there, I believe. So that's the void I was talking about, the void sign. It's just showing us as a void above. So I don't know. I might leave a link to this architectural um, drawing in my description to this video. So if you want, you can download it and also practice with that with the architectural drawing. So I will leave a link to this very architectural layout plans. I need to take this off so it stops. Yeah, like I said, that's the void below. Stop getting causing confusion. So now I'm going to the first floor plan on the architectural layout. So I'm mapping out the boundaries of the first floor plan, the external perimeters. Why am I doing this? One, I will impose this on the ground floor plan to show me areas where we have cantilever, meaning to know areas that has been extended on the first floor level. So now I'm on the first floor plan doing like tracing the external perimeter of the plans. So I'm doing this carefully. So the red lines are the external perimeter. So I'll copy this now and superimpose it on my ground floor layout, structural layout, proposed structural layout. But I'll look for a point that I know is on the first floor, and the same point is also on the ground floor. This point are mostly found around the staircase area. So as you can see on the ground floor layout, you can see there are some extensions around. So those are our cantilevered area on the first floor level. So I just picked another point again just to show you can pick any point, but you have to make sure these points are also, I mean, they also appear on the other part of the drawing. So that's the part is a void. I'm cutting that line off. I use the break command. I know this part is a bit tricky what I just said now, but I believe you get a hang of it. So I'm still working on the ground floor layout, but I'm just trying to find out the perimeters of the first floor above. You know, let's just keep going. Later you find out why you see why I had to do that. You know? So now I'm extending. I'm offsetting um, the lines for my grid lines. So those lines I'm just offsetting. They're just for my grid lines. They're not for any other thing. So now I'm offsetting my grid lines now. So our wall is 225 center. No, 225 as the width of the wall. So to now get the center, I have to divide 225 by 2. So I got 112.5. So I'm now putting my grid lines at the center of the walls. I'm now offsetting 112.5. So for example, if the wall is 230, center will be 115. That's half of that. So you offset 115, but in this case, 225, 112.5. So now you see why I was saying our beams, the lines should be one single line. If you're having multiple broken lines, if you can't offset it, you have to start offsetting multiple lines. But if it's just one line, if you click on offset, it offsets the whole beam. I don't know if you get what I mean. See, let me offset this now. Okay, I'm extending. Let me extend them out extend the green lines out. Then later I'll go back to what I was saying. So I'm extending them to those lines I drew. So all of them can be on the same, have the same distance and all that. So here now we are having two beams. So they must have one grid line. Every beam must have, since they're on the same level. So we would just run one grid line straight across both beams. So for having one grid line for this beam and one grid line for the other beam, you just have one single grid line running across both beams. As you can see, look at it. One grid line running straight across. I'm not sure I need. I'm not sure I need this line there. Mm, I'm still extending the grid lines to meet the other one outside. So you see, I just checked. The grid line is now at the center of this other beam. See, it's not at the center, so I have to I have to make sure this beam has to have a different grid line since they are not is the other grid line is not on the same level as that beam. I don't know if I said the beam doesn't cut the grid line doesn't cut across at the center of this other beam. So now I'm forced to create a new grid line for that beam. But when the grid line cuts across the other beam at the center, you just let it go. I'm still extending my beams. Now I'm match propertying them. That is, the grid lines are in green, and they are in broken continuous line for the grid lines. So I'm using color now to identify each member. So for the grid lines, they are green. Then the for the slab, where the part of the slab that I mean beam now that is discontinuous. What I mean by discontinuous is maybe the beam is at the edge of the building, that's at the back of as maybe at the external perimeter of the building. I use the pink line. So if the beam is within the building, within the layout, or within the layout, I use the blue line, blue broken line. Let's continue. You see what I mean. So now I just brought out a project. So I want to match property this now. So as you can see, look at the external lines. I'm making them this magenta color. But if the same applies to the stairs, I use the magenta color. So here it's not working. So I have to explode it. So the explode command is X, enter. That's X for X-ray. So now I want to explode this staircase. So now for the internal part of the beams layout, I use the broken blue line or turquoise, and I don't know what you call it. So as you can see, our picture is coming alive bit by bit. So some companies, they use different colors. Some might use green for their walls. Some might use different colors, depending on the company you work for. But personally, these are the colors I use. My broken lines are green. Walls, continuous walls are blue. Then the external walls are, beams are magenta. You see, I'm trying to separate both lines there because one was inside, the other one was outside. I had to break them to be able to match up at them. So now I'm trying to create the column. So column is 225 by 225. Same as it also, since the column is going to be embedded within the wall. So I use the polyline there to create my column 225, 225, 225, 225, then form that box. Then I'm using the hash command to fill within the columns. So now I'm changing it now to the column layer. So that's our column. Basically, polyline 225 by 225. Then I hatch, fill the column, solid hatch. So now I'm inserting the column strategically, you know, not just putting columns anywhere, because we also have to take the cost of these columns into consideration. And also take note of areas where we might have maybe windows or doors. So we try as much as possible not to have our columns in those areas. So once I'm done starting this column, I'll also superimpose these columns on the ground floor plan to see if they're all flush within the block walls. That's the ground floor plan above. So once I'm done inserting the columns, I would do that to confirm that our columns are hidden within the walls. So the column size varies depending on the load that's being transferred to that column. So by default, I'm just using 225 by 225. But since this is a one-story building, I'm not sure we can have any column above that size. But when we start going to like 2 floors, I mean 2 stories, we might start having maybe 225 by 300, or the column size start changing because now the more loads are being transferred to the columns. Please don't forget to like and subscribe if you are enjoying this video to help us do more videos like this. If you can see, a lot of work has been put into this video. We really appreciate your subscription and the like button too. Don't forget to do that. Thank you. So that beam was in between a broken line, discontinuous and continuous parts. So I had to break them so they can. So I want a grid line now for this beam, just in case. I know my case for the dimension, to get the dimension. So after this, now we'll go to the dimension, just the external dimension of the grids. So mind you, this is still the ground floor, and if I must add, we use the ground floor structural layout to generate the first floor plan. Or for example, if it's a 2-story building, you use your ground floor structural layout to generate your first floor structural layout, taking consideration of cantilevers. So for your first floor layout, Sorry, I mean for your first floor layout, you now use your second floor architectural layout. I think I'm mixing it up now. So basically, use the floor above to generate the one below. Sorry, I mean the floor below to generate the one above. I'm just mixing everything up. The floor below to generate the floor above. The layout of the floor above. Sorry about that. So basically your second floor layout will be your first floor architectural layout, the plan. So if you don't get that, maybe I might do another video on maybe for a building with up to 3 floors. Unless maybe there I can explain better. Maybe a duplex with a pen floor, you know. So I'm just fine tuning everything just to make it look. So I think we need a column here, yeah. Yeah, I forgot too much property there line. So this is our ground floor layout. I know it's looking like a first floor layout because of the cantilevers, but if you remember I said use the ground floor layout to do the first floor um, structural layout, but we have to take note of the cantilevers or maybe any other features, but you must always refer to the architecture of the first floor. So now I'm inserting my grid lines. Sorry, I mean my dimensions. So what I just did is dimension continue. So when I click on one, I just click on continue. It just keeps continue with the same dimension. So after this, I will do the other axis. For the y-axis. The other side now. So now I'll multiply that. But if you already have your layouts set with the right dimension, you can use that. But I'm using the dimensional layout from a previous job I've done before. So now I'm copying this now into 2 as I'm duplicating it now. But before that, I forgot to add my grid lines. That's the numbers of the grid lines, or call out or whatever you call it. So that is just basically drawing a circle and putting a text in front. Just draw a circle and text, just AutoCAD text. Then you can type the text, increase the size, boldness, or whatever. So that's how you do that. You don't want to spend much time doing all that, you know. So once we've done one, we just duplicate it for the others. Our layout is looking alive. It's a bit tricky here. Okay. So I'll also do the same for the other 6 axes, the y-axis. Mind you, let's continue. I'll say what I want to say when we get there. Mind you, if y-axis is numerical, the x-axis is always alphabetical, or sometimes the architect will provide you with grid lines to use. So where you don't have a grid line showing, you can use maybe the grid line before that grid line. Maybe if it's the grid line before that grid line is 3. So where you don't have a grid line or a new grid line that's not from the architectural side, you can just use prime, call it prime or A, to show that grid line is different, it's new, it's not from the architectural part. So, but in this case, we're assuming our grid line is just architect didn't give us a grid line to work with. We're just using our own grid line. So here we have 4, there we have 4 prime. You know, instead of putting 5 there, because I'm just assuming that architect didn't give us there's no grid line at that middle there. So we'll just use prime there. So I have 6 prime, yes, that can also fly. 7. 7 prime. It can be 8. 9. Then that should be 9 prime. With constant parties, you get the text. You understand what I'm doing better. So like I said, if this axis is since the x-axis are numerical, the y-axis should be alphabetical. Why? Just to avoid so there'll be less confusion. You know, so once you look at the beam, the axis at the top, you easily know where it's facing and its orientation and all that. So now I'm done with this one. I just copy it to the other end. Then now I'm checking to see the beam that are not lapping with the grid. So this B is not lapping with the grid, so that's gonna be a new grid line. So I'll call it B prime. C is nowhere to be found, so I delete that or move it down and call it. But before then, I'll check if there's another C prime prime. Okay, we have a C prime down there. So D is also not. So this one will be C prime prime. Or C prime prime, yeah. E is okay, F is okay. Yeah. So this is our ground floor layout almost completed. So the next video I will round up with the first floor layout.